Now we're going to find and interpret the Pearson coefficient of skewness. So we recall back the shape of distribution. Before this, we have three types of distribution, which is the first one, symmetrical distribution, or we can call it normal distribution. Second, positively skewed distribution, or skewed to the right. Then negatively skewed distribution, or skewed to the left. So if we look on our box and whisker. So if we analyze the data using box and whisker, you can notice that the box will be having the same length, then median will be at the center of the box. So in this kind of box, we can look it and we can describe the distribution is symmetrical. So if we're using the statistic on mean, mode, median, so their value will be equal to each other. So for second distribution, if our distribution is skewed to the right, when we analyze using box and whisker, you can notice that our box on right hand side will be bigger than left hand side. So here will be our median. So if you're using statistic, median always at the center, but the mode, so the mode you can see the highest of the graphs. The highest of the graph will be less than median, so median at the center, and then less than mean. So for the third distribution, skewed to the left, if we analyze by using box and whisker, we look on the box, you can notice that the box on the left hand side will be bigger than right hand side. Median will be at middle. Then if you're using statistic, mean, median, mode, so median of course will be at the center, so the mode will be on the right hand side. So mean will be less than median and less than mode. So we will have stem and leaf distribution. We can see the distribution from box and whisker, and we can see the distribution from mean, mode, median. So we have three options to analyze our data. So beside that, we also can come up with Pearson coefficient of skewness. We have two formula here, where Pearson coefficient of skewness, the symbol will be written as SK. So what we need from our data will be mean, median, and standard deviation for the first formula, which is multiplied by 3. For the second formula, it will be mean, mode, and standard deviation. So definitely you need your standard deviation. So when your data have mean and median, we will use this formula. When our data have mean and mode, we will use this formula. Depends on the situation from the questions. So after we get this Pearson or coefficient of skewness, we get the reading. So if the reading is very close to 0, no matter it's negatively or positively, so that we can conclude that the distribution is approximately to normal. So of course, if you get the value is positive, means it will be positively skewed. If you get the result is negative value, it will be negatively skewed. So only for close to 0, we will define it as normal or equals to 0. So the skew will be in the middle here. So close to 0, normal. So the value positively will be positive skewed. So if your value is negative, let's say, so it's 0.5, 1, so negative 0.5, negative 1, so all those we will conclude the data will be negatively skewed. So in the middle, we will consider it as normal distribution.